Welcome everyone. This video is going to be slightly different. We're going to be covering some of the telemetry RF features of a PowerBox system. It really is at this point in time the ultimate telemetry system in regards to the RF link. No other radio can match its telemetry features for our RF link. And this video will show you why. Anyway, to get the ball rolling, in front of us we've just got a standard PBR26D receiver. A lot of users would be familiar with this receiver. It's basically a serial bus receiver, so there's no servo outputs. However, as you can see, we've just got the standard two coaxial antennas. Sort of common with many other radio systems, you know, where you can have a receiver that's hooked up to, say, a PowerBox unit or some sort of power distribution unit in your aircraft. And typically you would use two receivers, second one for redundancy. So normally you'd have, say, two of these receivers and a cable would come out of the bus from each receiver, and those two cables would then connect off to your PowerBox unit or whatever power distribution unit you have, and that forms a basis for redundancy. If one receiver gets blocked or the RF signal gets blocked on these antennas, then the other one takes over and vice versa. That's how it works on most systems. Now, one thing that differentiates PowerBox receivers is these models with a D on it. This box actually has two physical receiver circuits inside it. It's not just one receiver, it's actually two receivers. So pictured in front of us now, we actually have four independent receivers. And later on, I'll show you on my core transmitters display how you can actually receive independent RSSI, link quality indication, holds, and figures such as that, all recorded and logged independently for each one of these antennas. No other system currently on the market can do that. Okay. Now, just to show you on paper how different these receivers are, I might just drag in front of us a piece of paper and draw a quick diagram. So let's take a look at how a standard receiver with two antennas that you find on most other systems are configured. So let's have our little antenna symbols. So normally you'd have, say, two little coaxial antennas coming out of the box, and I better move that diagram down a little bit so you can see it. Okay, so there's our two little antennas. So they're our little coaxial antennas that you normally have coming out of your receiver unit. And typically with most systems they'll have a receiver circuit. So it'll be an IC, an integrated circuit, and that forms the receiver, the main receiver section. And that decodes the radio stream and spits it out, and eventually that data goes to your flight controller or your PowerBox distribution unit, etc., etc. Now, typically, how do we get the two antennas connected to this receiver? We've only got the one receiver in most of these units. But what they do is they normally have an electronic switch, and sometimes this switch is actually within the integrated circuit, sometimes it's external. Sometimes they use pin diodes. I won't bother drawing pin diodes because that'll probably just confuse everyone. But let's just put a little mechanical switch here. It is electronic, so it does switch automatically. So this is how typically a standard receiver works as found in other systems. So what generally happens is when you're flying around, you got your transmitter sending a signal out, and both of these antennas are receiving the signal. If one antenna can't receive a very good signal, the system will then switch automatically to the other receiver. It does this in a blind way insofar as it just looks at the data coming from this receiver, says it's bad. If it's bad, it switches. However, it doesn't know if the data on here is any good or bad when it switches over. So you could be switching over to an antenna which has got no signal. And in that case, what can happen is it'll, go into a fail-safe condition. But that's basically how a standard receiver, as you find, say, with Futaba and many other systems, actually operate. there's nothing too complex there. Now this is where the PowerBox receivers differ. So the PBR26D, as I showed you before, has a D suffix to indicate a dual receiver circuit. So how they work. Let's draw our two antennas again. Hopefully you like my antenna symbols. Now, this is where they differ quite substantially from your typical receiver as found on just about all other systems. First of all, they don't go straight into a receiver IC. They go into a preamplifier. So there's an amplifier here, which boosts the incoming received signal strength and also improves the signal to noise ratio. And then, only after then, they go into two individual receive ICs. So two separate receiver ICs. I know my drawing's a little bit messy, but this is just to highlight the point. And then out of these, basically you then have the data coming out, which is then combined. And another IC, little microprocessor, little CPU. And then basically that's your signal out, going to your servos, or that could be a bus signal like the P2 bus as far as PowerBox are concerned. You can also switch it to S bus, etc, etc. So the main difference to pick out here is these two paths are totally independent. So the advantage of this is the radio or the transmitter, when it gets telemetry back, the telemetry is actually sent back this way, out through the antennas. Both antennas send telemetry back to the PowerBox radio. So for each one of these receivers, we can have RSSI. We can also look at the link quality, or PowerBox term, they call it link quality indicator. And for instance, you can also measure other things as well. You can look at total link quality. So there's individual link quality for the two, then there's like a total link quality indicator. And I'll show you these a little bit later in the video. And that total link quality indicator basically compares the two LQIs from the two paths. But the main difference is we do have two individual receivers. Now with the PowerBox core radio, you can bind up to a maximum of 4 receivers. So if we take our 26D, it's treated as one unit. It takes up one slot. So we have 4 slots available for binding receivers in the PowerBox core. So in theory, you can bind up to 8 individual receivers if you use, say, 4 of these 26Ds with a PowerBox core. Okay, enough of my crude drawing. Let's move on back to the receiver. And let's talk a little bit more about some of the other features. Okay, now normally these receivers are connected via bus cable. So in PowerBox terminology, they call it a P2 bus. So normally you take your servo cable out of here and connect it to, say, your power distribution unit. And typically on a large aircraft, you might have your power distribution up front, somewhere, say, under the canopy or up in the nose somewhere. And that may not be an optimum solution for the positioning of these antennas. So, typically, with a lot of other systems as well, we can extend this cable. Now, one of the differences as far as PowerBox are concerned is the way they drive this bus allows you a much greater length than most other radio systems. So typically on the P2 bus, you can run a cable that's, I think it's been tested to about 10 meters in length. So you could mount this receiver, physically mount it 10 meters away from your power distribution box, and it'll still work fine. So that opens up a lot of opportunities if you want to mount this receiver, say, at the back of the aircraft. So 10 meters is quite a long distance. So, even in the large scale jet community, where you may have one of these up the back of the aircraft, 10 meters should give you plenty of flexibility. And don't forget also, you've got another option here where you use a second one. You can mount that somewhere else in the aircraft as well. And another real advantage of the system is PowerBox introduced this little PBR26XS, which is a full-blown 26-channel receiver with a single antenna. It's just a single receiver. However, it has a secondary function where you can use it as a satellite for the 26D. So you can actually plug this into the fast track port of the 26D, and I've shown you that in a previous video. And basically it becomes a satellite to this receiver. So you now actually, when it's connected to the 26D, we now actually have 3 receiver circuits, or 3 independent receivers connected to the system. So you could lose connectivity or an RF connection to these 2 antennas, so they get blocked or they fail or whatever. As long as this one's still working, and this one might be positioned, say, in a tail fin in your aircraft, the system won't lock out because it can receive a signal from your transmitter on this antenna. It basically connects into this and then goes back into the bus. Away you go. It's a really handy addition. The real advantage of the 26XS is its side profile. So it's very thin, and you know, it's quite a small unit, so it's quite easy to bury it inside the aircraft somewhere and you know, put it in a typical position where you struggle with many other receivers. Like I said, it's a full-blown 26-channel receiver with excellent sensitivity. Okay, now just moving on. A few other things to highlight, especially for large-scale aircraft, you know, typically where we use these more expensive radio systems, is the fact that there's a few little tips and tricks, or features I should say, not tips and tricks, but features available on the PowerBox receivers that really make life easy. Number one, there's no bind plug. So, you know, if this receiver's buried in my aircraft somewhere, I don't need to, you know, if I have to rebind it for whatever reason, I don't have to go and find the receiver and dig it out from my aircraft somewhere. Sometimes it might be totally inaccessible, you know, impractical to remove. There is no bind plug. Binding is simply done by switching the power to the receiver on and activating the bind process in the transmitter. Simple as that. Same goes for any firmware updates. You don't need to physically access the receiver. So to do a firmware update, it's handled by the transmitter. You just switch power on, you do it through the transmitter, away you go. Another thing is if the firmware fails, a lot of other radio systems, you've got to pull the receiver out, you've got to stuff around with bind plugs or whatever. In PowerBox architecture, even the firmware, if it fails, you can do a firmware recovery without needing access to the receiver. It's all done remotely via the transmitter. As long as you can switch power on and off to the receiver, you're good to go. And that makes life very easy, or a lot easier than many other systems. People sort of discount that. Oh yeah, you know, bind plug's no big deal. But in a lot of cases, it can be a pain in the rear end if you have to dick around with bind plugs and, you know, removing receivers out of the aircraft to do firmware updates and all that sort of stuff. With PowerBox, it's not an issue. You don't have to worry about that. So really, for a lot of aircraft, it makes sense to use this sort of architecture because it just makes life so much more easier. Okay, now we talked about the 2 independent receivers in this receiver. So any of the PowerBox receivers that end in a D feature 2 independent receivers. So what I might do is I might just drag out my core now, and we'll switch to the core screen, and let's take a look at the screen on the core and binding the receivers, and I'll talk a little bit about the telemetry. Oh, one other important thing, the telemetry on here. So don't forget, telemetry is transmitted from your receiver. So this is on all systems. The telemetry is transmitted from one of the receivers, usually on most other systems, through your antenna. And typically on just about all other systems, the power that's being transmitted from the receiver is a lower power than what your radio puts out. So typically your telemetry link is not as strong as your main RF link from the transmitter. However, with PowerBox, they've put in a full-blown transmitter for each one of these antennas. So there's actually two in here, and they transmit telemetry at the full legal power limit. So your telemetry link has the same operating distance as your main link from the transmitter. There's no difference whatsoever. And they did that mainly so you probably see on the PowerBox YouTube site where they did a quick range test with these receivers, and they got just over 9 kilometers without any dramas, and the telemetry was still functioning. And that's because the telemetry was transmitted back to the transmitter at full power, no different to how the transmitter transmits. So again, that's another differentiating feature for the PowerBox radio system. Okay, now I'll just grab my core and position it in front of the camera, and let's have a look at binding these receivers. So now you can see my core transmitter screen in front of us, and I've gone into the receiver binding screen. So you can see there's 4 columns or 4 slots. We've got slot A, B, C and D, and each one of those slots we can bind a receiver to. So what I'll be doing for this example is I've got 2 of those PBR26Ds, and we're also going to connect 2 of the little satellite receivers as well. So 1 to each of the 26Ds. And so effectively we'll have 4 slots used. So 2 for both 26Ds and 2 for the 2 satellites. And that'll give us a total of 6 independent receivers for this example. Okay, now just to show you how easy it is to bind a receiver, I'm just going to I'll just grab my little 26 PBR26D, which is a little bit out of focus here. Anyway, you saw that earlier. I'll just apply power to it. I'll just switch the switch on. And when you turn the receiver on, you get 10 seconds to bind it. So I've just switched it on. I just hit the bind button, just press it a little bit harder, and pretty much that's it. We've bound that first 26D into position A or slot A. So now we can basically use the radio system. However, I also want to connect the satellite. So we're going to hook up a satellite. So the little 26XS, as you saw previously, so this little guy here, I'm just going to turn the receiver, the 26D off, and I'll just plug it into the what they call the fast track port, and that'll give us satellite functionality with that receiver. Okay, plugged it in. Now we just need to bind it to the radio. So I've already got the first receiver bound, but I'm just going to turn both receivers on again. And what will happen is when I turn it on, this receiver will connect almost immediately, and then we'll go ahead and bind the little satellite receiver, which is currently not bound to the system. Okay, I'm going to switch it on. So I'm going to switch both of the receivers on, and we're going to proceed to bind the little satellite receiver. There you go, switched it on. And there you go, and there's a little picture of the satellite receiver there, the little 26XS, which is actually a full-blown receiver, a single receiver that is. And now we have 3 receivers, even though there's physically only 2 units, from a technical perspective, it's actually 3 independent receivers. And later on, actually we'll do it now, we can have a look at the telemetry screen, which I've already set up to save a little bit of time. So if I just go back to the home screen, you'll notice here we've got the little moniker in the top of the widget. You'll see PBR 26D with a little A. So that shows us the 26D, which is bound in slot A. So that's RSSI 1 for one of the antennas, and on the right hand side is RSSI 2 for the secondary antenna for that receiver. So we've got the 2 antennas, and we've got 2 RSSI values. Same goes for the link quality. So link quality 1 and link quality 2, LQI 1 and 2. Again, for the PBR26D in slot A, or position, the binding position A, and currently shows it at around about 100%. And we've got some lost frames there, and that's because during binding when I was switching it on or off. But if I turn it off, turn it back on, you'll see everything sort of resets. And you might see these increment a little bit. I'm in my garage, there's a lot of reflections in here because of all the metalwork. So sometimes you'll see this count up a little bit. However, in this part of the screen, we've got the full complement of basically the RF parameters that I typically monitor on a flight. And of course, as most PowerBox users are aware, you can double click the widget and you can get maximum and minimum values. So you notice the minimum is minus 128 dBm because that was when I just switched it off. Maximum minus 17, which is a high signal strength from an RF perspective. Oh, and one other thing is the PowerBox system, the telemetry system, uses industry standard units. There's no scaling, it's just measured in dBm. So RSSI here is measured in dBm. Again, industry standard radio units. There's no scaling, so when you look at your logs, you'll get a true reading of dBm. There's no weird numbers or letters you have to decipher and work out exactly what level you're actually receiving. It's in dBm. Not many other radio systems actually record the RSSI in straight dBm. A lot of them use some sort of scaling mechanism. Now, over on the right hand side of the screen, remember we bound the little satellite receiver, the 26XS, and you'll notice a little B here, so indicating that it's in the receiver that's in slot B. And again, we've got RSSI for that receiver, the LQI, and for instance, lost frames. And of course, there's other parameters as well. Most PowerBox users are aware. If we go into telemetry and select, say, the satellite receiver, you can look at the battery voltage. If we look at the main receiver, again, you can look at battery voltage. These parameters we're looking at. There's a total LQI. So the total LQI compares LQI 1 and 2 and gives you an average of the two in effect. So basically, if LQI 1 goes bad but LQI 2 is good, the total LQI is good. There's an external receiver error and a status box as well, which I've activated on the home screen. So you see in this little box here, you can see it'll toggle between RX OK and a 0, indicating there's no problems with the external receiver that's connected to it. Again, you can display multiple telemetry values in the one widget, and the system will automatically cycle through them. So for this one here, I've just got 2 values. I could add more if I wanted to. It's just a user preference thing. Okay, so at the moment, we have 3 receivers connected to the PowerBox core transmitter, and each one of those receivers is sending telemetry back to the system. On the majority of other radio systems out there, only the one receiver can send telemetry back to the transmitter. And this is another major differentiation between PowerBox and other RC systems. The ability to send back telemetry from each receiver allows us to have these individual RF parameters all shown on the screen for each individual receiver, and in a lot of cases, for a lot of other systems, that's simply not available. Okay, now what I might do is let's go back to the binding screen. Oops, if I go in the right way. Go back to the receiver menu, and I'll just switch the receivers off, and I'm just going to connect the second 26D to the system. So I'm just connecting power to it at the moment, and we'll switch that guy on as well, and we'll bind it into slot C. So I've just switched all the receivers on, hit the bind button, and there you go, bound in slot C. Now, one more thing, let's bind my last satellite. So I've got another 26XS satellite. I'm plugging that into the fast track port of the 26D. If you're not familiar with the connections, have a look at one of my early videos where I show you how to plug the satellite in and basically how to connect the receivers up to your system. Okay, I've just plugged it in. Again, let's power up all the receivers and hit the bind button. And there you go, we've got the remaining 26XS, which we're using in a satellite configuration for this particular example. Across the bottom of the screen, you'll see the serial numbers for the receivers. And that's just basically the unique serial number given to each receiver. In some cases, it's handy if there's a recall or any problem with it. Obviously, you can, if they had a bad batch, for instance, they can track the serial numbers. Otherwise, the serial number is not really that useful. Now, I did mention firmware updates, so I might just show you on the screen here. Oops, hit the, I'll just get out of that. If we go back to the System menu or Settings menu, go into System, we go to the Software Update screen, so we hit the check button, and in here, this is where we can update the transmitter using Wi-Fi. And if we go down a little bit further, you'll notice here we've got receiver A, B, C, and D. So they're the four slots, A, B, C, and D. And you currently can see what firmware they're running. So the two, my voice is going funny, the two receivers in slot A and C, they're the 26Ds, and they're running the current firmware version 4.1. And the two satellites bound in receiver slot B and receiver slot D, they are currently also running their current firmware version, which is version 1.0. So there hasn't been any bugs found with them since they've been released, so they're still on 1.0. So typically, if you want to update a receiver, you hit update here. So if we wanted to update the receiver in slot A, just hit update. Currently inside my core, I've got these firmware files inside the transmitter. So I can roll back to an early firmware version if I wanted to. And, it's just a simple matter of clicking on the version, then hitting the update. If you click on the details button, it gives you a bit, a few fixes or what the firmware did. So in this particular case, version 4.0 had these features added to the particular receiver, and also had a couple of little gyro features fixed as well. Simple as that, very simple. And of course, I did mention the firmware recovery. You can do this by hitting the run button there. It's important to note that if you do a firmware recovery, to only have one receiver connected to the system when you're doing a firmware recovery, because what basically happens is you boot up the receiver and it's not bound to the radio. The transmitter sort of sends out a handshaking signal, and any receiver that's switched on will accept that handshaking signal. So it's important when you're doing firmware recovery, just have the faulty receiver or the one with the faulty firmware powered up. If you're doing a standard update, you can have multiple receivers connected. It's no dramas at all. Okay, let's go back to our home screen. So if you look carefully, we're on page 1 of 2. And I've actually added a second page. So if I scroll over to the second page, and you'll notice now we've got PBR 26D. So this was the second of the 26D receivers. So the one bound in slot C. And I've just got the same RF parameters on this screen as well. And again, the last slot, slot D, has the 26XS, which is the little skinny satellite receiver. And again, we've got the RF parameters for that particular receiver. So we can swipe and switch between main and secondary screens like this. Obviously, you have your more screens. You can have other parameters, other telemetry widgets and whatever. But in this example, I've just got the receivers connected to the system. And you'll notice sometimes these figures are flickering and that's because, like I mentioned before, because I'm in the shed, what's happening is the power output from these receivers is pretty high, and you actually get interruptions in the telemetry because it can corrupt the telemetry. All right. One other thing to mention, logging. So as you know, log files stored, so each of these parameters are logged. You don't have to have them displayed on the screen. So if I remove a widget, let's delete this guy here, and say delete the other RSSI figure for this particular receiver. So at the moment, the two RSSI figures for the receiver in slot C are not displayed on the screen. However, they are being logged. So any telemetry values that are capable of being transmitted are always transmitted, irrespective of what you've got selected on the screen. Simple as that. Okay, I think that about does it. Probably the big takeaway from a telemetry perspective is that with a PowerBox system, all the receivers transmit telemetry at full power back to the transmitter. The system's not limited to just having one receiver send telemetry back. And the advantage of that is the ability to then monitor all the RF paths. So basically all your antennas, every single antenna that's involved in the system can be monitored individually. And as you saw on the screens here, we can look at the individual RF parameters, simple as making a widget or reviewing that in the stored logs after your flight. So if you have a large aircraft or a giant scale aircraft, it's really handy being able to have these parameters visible to you, because if you think about many other systems, so one of the other systems I fly with is Firmware. And with a Firmware system, I can select a primary and secondary receiver. So I can have two receivers connected to a power distribution box. So typically, Firmware have recently brought out a DLPH1 and a 2. So it's just a little distribution box, neat little unit, and you can connect two receivers to it. And in effect, you have basically the two receivers, one for redundancy. Now the problem with that is when you go flying, you're only ever monitoring the one receiver. So when you're flying and you're looking at your logs and whatever, you're sort of limited to what you can do, because you can only ever look at the one receiver. So if the one receiver never fails, say the primary receiver's maybe connected correctly, you take off and it never switches over to the other receiver, you'll never ever know whether the other receiver's been installed correctly. Have you installed the antennas in a optimum location for that second receiver? You can never ever tell. Whereas with PowerBox radio system, you just basically, you just look at your widgets after your flight or review your logs, and you've got all the individual logs for each one of those single antennas. As I showed you in this particular example, we've got, in effect, the 6 receivers connected to the system. So you've got two independent receivers here, another 2 independent ones there, then you've got the 2 satellites. So for this example, we've got 6 antennas, 6 individual RF paths, and as you saw from the widgets, all those RF paths are basically available for viewing and logging. So it's really a no-brainer. You go fly your aircraft, say your maiden aircraft, you land, you review the logs, you can quickly tell, hey, look, the third receiver's antenna, say the left-hand side antenna on the third receiver is not in an optimal location because I'm getting poor RSSI or poor link quality. I need to reposition it in the aircraft. So you can always keep an eye on every single receiver, every single antenna inside your aircraft. It's a real big handy feature. And I've got an electronics background, a radio background as well. So for me, that's a really important feature to have on a radio. And at this point in time, PowerBox are the only ones to implement the telemetry in such a way that allows you to do that. Okay, that's probably enough of me rambling on in this video. So hopefully, for experienced PowerBox users, you may have learnt a little bit, maybe not. But if you've got any friends that are considering purchasing maybe a PowerBox radio or buying into the PowerBox system, you can show them this video and just, basically it highlights quite a few differences between your, run-of-the-mill radio systems that are available to people. Okay, once again, thanks to all the viewers, thanks for watching, and catch you on the next video.